All right, so now that we've reviewed part one, in part two, the next part of this very small unit is the idea of rotation and rotation symmetry. Part of this, like in part one, is visual, looking at shapes and determining sort of if there's symmetry there. And then the other part of it is geometrical, where you're actually going to have to, once again, plot things and do this. For doing the assignment for part two, you will need a protractor, okay? So I'll show you how that works in a second, which would be part of a geometry set, which is something you should have had. Yeah. You had to be logged in, which you weren't, so. Okay. So once again, this is what the math curriculum says. You've seen this before. I showed it to you in part one, so it's not a new piece. Basically, demonstrate an understanding of both line symmetry and rotation symmetry. So today we focus on rotation symmetry and what this means. In your textbook, it actually has two chapters, one for line and one for rotation. Once again, I really recommend the textbook because it's very visual there. Okay, so what I mean by rotation symmetry is where a pattern is repeated in a rotational way or a rotational pattern, okay? Shh, guys, please. You can see this occurring in lots of different visual designs. You can even see this occurring somewhat in nature, in things like flowers and seashells and things like that, okay? For rotational symmetry to occur, you'd have to turn the object that you're rotating along a center point, okay? Now the center point does not have to be in the middle of the thing you're turning, okay? And we'll talk about that in a minute. But the center of rotation is the point around which it rotates. So a great example of that would be the hand on a clock, right? If you guys look up at that clock right now, you can see the second hand moving. It's not rotating in the middle of that hand. It's rotating on one end of it, okay? So the center of rotation is not the center of the object. It's the spot that it's being used to rotate with. The order of rotation is the number of times it's been rotated. So in this object, what would be the order of rotation? Can anyone take a guess? What would you say? Infinite. No, not infinite. This is the shape right here. How many times has it been rotated in the visual? 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct. Okay? That's the kind of questions you can expect. Okay, well, let's take a look at some more stuff you can expect. The angle of rotation is the measurement of the angle needed to turn the shape into itself, okay? This can actually be calculated mathematically. You can calculate the angle of rotation by just putting it in a fraction as the denominator with 360 as the numerator. Why 360? Because that's the total distance around a circle, right, in degrees. And if you just divide them, you'll get the angle of rotation. So here's the shape. I made this shape, and I'm going to rotate it right here on this point here. Okay, so that's the shape itself, and I'm going to rotate it there. Okay, so here it is, and I've rotated it 8 times along its center point there. Okay, along its center of rotation. So the question is, what angle did I rotate it on? Okay, well, as I've said before, we can calculate this. We can calculate the angle by putting the order of rotation under 360 degrees. So since I rotated it 8 times, 360 divided by 8 is 45. So I rotated this on a 45-degree angle each time. Now some of you might have been able to pick that up just visually. Just like, oh, Wax just turned it 45 degrees, then he turned it another 45, then another 45, all the way around. That's how we do it. But if it's some angle that's like this was a nice simple number, like 8 times. But if it's a different number, that's a way you could calculate it. I wouldn't expect a really complex question like this on your final exam or on any of my unit tests. It will most likely be a simpler question like this. Ones that you can almost do visually, okay? But you may not have to do the math on it. Okay, so a rotation in geometry is a transformation where a figure is rotated around a point, as I've said before, okay? To rotate an object, you need to know which way it's going and how much, right? Because if I said to you, take this Kleenex box and rotate it, you'd want to know how many times do I turn it and how much do I turn it, which direction do I turn it, how many times. So these are the things you need to know when you rotate an object. Okay, So here's the more formal way to do it in geometry, okay? So here's a 3-point object, ABC, a triangle. I want to rotate this using this as the rotation point. So you can almost imagine that it's like a flag, and that it's attached to that thing with a pole. And I'm going to take this whole triangle and rotate it, okay? I'm going to turn it. It's not turning in the center of itself. It's not doing that. It's rotating at that point. So the way you could do this is take the points of the triangles one at a time and draw a line connecting it to the rotation point. So I'll draw a line there connecting it. Then I measure the distance. So you'll have to measure what the distance is between these 2 points using a ruler, okay? Then I will lay a protractor on the line I just drew, okay, right on the line, and measure the angle, okay? So I'm going to say, oh, okay, I'm going to measure the angle there. From that angle, I will draw out another line, okay? So hang on. So there we go. So I'll draw the other line out, and then I will match the distance. So the distance will match, and that will create the rotation there, okay? So hang on, did it? Now you want to do that for all 3 points, okay? So we'll do some examples of that in a minute, just so you can see how it works. And then the final thing, and I just want to back up for 1 sec, right to the very beginning, just to show you in terms of what this is covered in the curriculum, okay? There's this little point, sub-point down here in the curriculum that says, identify a line of symmetry in the order of angle in a tessellation, okay? And then it says, describe a piece of artwork, okay, that could possibly, so this word tessellation appears in the curriculum, and I would hate for you guys to get a final exam question that says this word, and you guys didn't know what it meant, okay? So that's why I've thrown this little piece in at the end, what is a tessellation? It's an art thing, but I just want to show you what the tessellation is. So a tessellation is essentially a repeating pattern, okay? You are standing on a tessellation right now. The tiles of this floor are a repeating pattern, okay? There's all kinds of ways you can create these repeating patterns. They don't have to match up perfectly, okay? You generally see these in artwork and things like wallpaper or tile designs and stuff like that. So I've got some examples here for you. They could be simple shapes like this that are repeating tessellations, okay? What happened there? That's not a good, what happened there? Here's some more complex sort of artwork that does that, right? So here's this like little kitty cat that's repeating, the black and the blue cat repeating themselves, right? Or the seahorses, I don't know what those are, the seashells here. So there's a repeating tessellation pattern there. You're not going to be expected to do this, to create these. This isn't an art class, but you should be able to recognize these as tessellations. Most likely the thing that you will get in an exam will be something simpler, a simpler shape there. Okay, wrapping with a couple examples today. Here's an example geometric question. It says, rotate this triangle 55 degrees on rotation point 1, 1. So first thing you need to do is find spot 1, 1, which is right there, right? That's where rotation spot 1, 1 is, okay? Then I would draw a line. We'll start with C, and then connect C with the rotation point, put a protractor down, measure an angle of 55 degrees, draw a line coming off of that at 55 degrees, and it would be the exact same distance from here to here as the new point there. You're really going to have to practice this to get it. And then it should rotate, okay? Did I not, oh yeah, there it is. So there's the new triangle up there, okay? So it didn't rotate much, just a little bit more than 45 degrees. Okay, here's another one. Translate this triangle. So this is one of those slides from part 1 to create a new triangle. Then reflect it. So that was what we covered in part 1. And then rotate it. So another thing they could do is they could give you multiple translations and transformations at once. So this one says translate it, then flip it, then rotate it. So I don't have the example animation up here for that one. But this is an example of kind of a more complex type question that they could give you. All the more reason this needs practice. Showing you will be something I can do tomorrow in class. I'll show you some examples of this directly from your assignment sheets, these kinds of ones. I don't have one this complicated on your assignment sheet. But it really requires practice, because when you guys get to the test and you have this in front of you, if you haven't done these, you are going to leave that question most likely blank. It's not the kind of thing you can guess at, like maybe you could have done in our algebra units and maybe hope for the right answer, you need to try these out. Okay? They're not hard, they just need practice. Okay? So the key concepts today is this idea of rotation symmetry, the center of rotation, the order of rotation, the angle of rotation, and the idea of a tessellation. Okay? So these are kind of terms that you need to be familiar with. Again, that's why I'd recommend doing the notes for this part. It's not a lot of notes, but it'll help you to remember these terms. Okay? This unit is not about like doing a bunch of math. It's about actually doing these types of geometric sort of examples and knowing the terminology there. Okay? All right, we are done part 2. Now, let me show you what the assignment looks like. We're done the unit, too. For this unit,